We're on page 19 of our notes. The new concept for us is rate of change. It gives us two pieces of information. It tells us how much change occurs and how quickly or how slowly it takes for that change to occur. So again, the two things that rates of change tell us are, first, how much change occurs, and two, how much time does that take? So take a look at number one. You're playing an arcade game. You win and these quarters start to spew out, so you catch them in your purse. Every 1 second, you catch 6 quarters in your purse. Let's put that together into a rate of change. We could say that per 1 second, we add 6 quarters. In number 2, we've got the same situation, but there's a hole in your purse, and 3 quarters fall out every 2 seconds. So how could we put those things into a single rate? Well, we would say per 2 seconds, or every 2 seconds, we lose 3 quarters. Notice that the two pieces of information are still present. In the numerator, we put how much change occurs. That's the delta. How many quarters do we gain or lose? Then we divide by how much time it takes for the change to occur. If you want to know how quickly my height grows, well, here's how we would put that into a variable. I would take the change in height, and if I want to make it a rate, I divide by how long it took for the change to occur. So maybe I grow 1 inch every 1 year. Or if you want to know how quickly I eat my food, you might say, well, okay, let's time it, and after some period of time, delta t, how much mass is there, how much mass have I eaten? So what's the change in mass per unit of time? So this is how we write rates of change. As soon as you see the word rate, we need delta t in the denominator. In the numerator, you put the change. Take a moment and work through this one. Next, let's get down the definitions of speed and velocity, and we'll see why we've just discussed rates. Here they are. Speed is the rate at which distance is traveled, the rate of d, distance. Velocity is the rate at which position changes. So what do you think the equations are? Also, take a moment to notice. Speed uses distance, whereas velocity uses position. Do you think they both have direction? Does one of them have direction? First, let's put this down. Speed does not have direction. Just like distance, it's always positive. Always positive. By contrast, velocity does have direction. It can be positive or negative. And that positive or negative tells us the direction. Moreover, we can have it along the x direction. We could have velocity along the y direction. So we'll have to distinguish. Now let's go to the equations. The variable for speed is v. If we see the rate right here, speed is the rate, we know we have to divide in the denominator by what? Oh yeah, by delta t. And it's the rate at which distance is traveled. So that's our equation. For velocity, we use a v as well, but we'll fix it here in just a moment. Velocity is the rate. If we see the rate, we know we have to divide by delta t. Velocity is the rate at which position, that's x, changes. That's the delta. But we could also have, for velocity, the rate, so delta t down below, the rate at which vertical position changes, or general position. We'll write down just these two for now. We'll get back to general position in Unit 2. So on the left side, we need to distinguish by putting a subscript of x. Here we put a subscript of y. And there's one final thing that we'll do to distinguish. Right now, I hate this. Ugh, I've got a v for both. That's really confusing. Let's add something to remind ourselves which is which. For velocity down below, we put an arrow over top the letter. We do that because velocity has direction, and so do arrows. If we look at the equations, what's the unit for speed or velocity? Well, distance is in meters, time, that's in seconds. Same down below. We've got displacement, that's in meters, per time, well, that's seconds. So for both, the equation, the unit rather, both have units of meters per second. That's distance over time, right? Displacement over time. Or we could do kilometers per hour or miles per hour or anything else. But this will be kind of our standard unit that we go to.